Okay, so today we will be going over black holes, as I'm sure most of you are aware. Now then, let's just go straight into it. How are they formed? There are two different ways in which a black hole can be formed. So the first way is if a star with more than 20 solar masses collapses. If you're unaware of what a solar mass is, go over the previous classes. I have explained it. But to put it simply, with a star that has more than 20 solar masses, when it collapses, neutron degeneracy pressure is not enough to stop the collapse itself. There is nothing in the universe, there is no force strong enough to stop the star from collapsing. So it collapses so hard that it forms a black hole, just to put it simply. The second method is when two neutron stars collide. I've got a picture down here. To put it simply, if two neutron stars are born next to each other or born in a binary system, I'll go over this at a later date. But if they are born next to each other, then their extreme gravity will mean that at some point they will collide into each other. When they do, and if they do, the forces of gravity acting on the neutron star matter will be so immense that it will collapse into a black hole. And now this is the confusing part. So as I'm sure you can see, in order to understand black holes, we need to understand gravity. How do we visualize it? With general relativity. This is how we visualize gravity.
I didn't get you what you were saying.
So if I go back, we need to, in order to understand what a black hole is, we need to visualize and understand what gravity is. And in order to do that, we need to go to general relativity. This is very, very advanced science. So please be careful. If you have any questions, feel free to stop me and ask those questions. So how do we visualize gravity? In order to do that, we need to understand space-time.
I have one last question. It was from the previous slide.
Yeah.
So, like, I didn't understand, like, how two neutron stars could collide into each other. So, could you explain that again?
Okay, so basically, this is something I haven't gone over yet, but stars can be born in what's known as a binary pair. Okay. So a binary system is basically where two stars orbit around a central point. Okay. And if two neutron stars are in a binary system, they can collide with each other, and that forms one black hole. Does that make sense?
Yeah, makes sense. Thank you.
Okay. But yeah, we need to visualize gravity. Again, this is very, very advanced. I took the liberty of giving you some demonstrations down here, but I will teach you how to do that soon. So first of all, how do we visualize gravity? In order to do that, we need to understand something called space-time, or the space-time continuum. This is a four-dimensional mathematical model of the universe. Yes, I repeat, four-dimensional. The four dimensions in question are length, width, height, and time. We're all aware of three-dimensional objects, correct?
Yeah.
Now, they all are affected by time, and that's the fourth dimension. Let me put it this way. A mountain is a three-dimensional object, correct? Now, over time, the mountain's length, width, and height is affected. Thus, time is the fourth dimension of the universe. Now, space-time is a combination of all of these dimensions, to put it simply. And the easiest way to think of it is as a blanket of sorts upon which everything in the universe rests. Everything in the universe travels along the blanket of space-time. And anything with mass will create little balls in the blanket. The little balls represent gravity, and the blanket is the space-time continuum. Now, let me give you an example. So can everyone see my mouse?
Yes.
Okay, so if you see down here, now down here, you will see that I've got a couple of books on a blanket. Okay, and this is a picture from the top and this is from the side. As you can see, they have their own mass and they make the blanket go in a little, okay? Whereas if you look over here, I've got a lot more books and they make a much bigger dip in the blanket. That dip is called a gravitational well, and these books represent stars and planets. So anything with more mass has more gravity, thus they create a bigger well. Does that make sense?
It's called a gravitational well, right?
Yes, it's called a gravitational well. So if anything has more mass, these gravitational wells become bigger. So for example, the gravitational well of our sun is much deeper than that of Earth's. Does that make sense? Okay,
Makes a lot of sense.
so here's the part that will not make sense. Because space-time is a four-dimensional plane with time as one of the dimensions, what this means is that a gravitational well affects not only the size of an object, but the way time acts on that object. To put it simply, in a gravitational well, time is slowed down. There's no other way to put it. So if this was down here, if this was a planet, then the time in down here is actually a little slower than up here, for example. And time here is much slower than up here. Okay. And if
So the time in the picture your mouse is pointing to is much slower than the first picture.
yes, because there's more mass, therefore more gravity. And the amount.
So it's basically like simple. The more the mass, the slower the period of time, like that.
You
And the
can't
bigger
say
and
that.
the deeper the gravitational well.
Yeah.
Can't think period of time though. That's where you're wrong. It's not. You can't say period of time. See, look. Period of time is what you're suggesting there is that time is fixed. No, what this is suggesting is that time is more fluid. So what you have to say is that time slows down. Time itself slows down. That's the simple way to put it. You can't think period of time. You have to think that time slows down.
Oh, okay, that makes more sense.
Okay, and the amount time is slowed down by, that's proportional to the strength of the gravitational field. The greater the gravitational field strength, the slower time is. Now, if anybody wants to redo this at home just to get a little bit of example, it's fairly simple. You take just a big blanket or any flexible material and stretch it out as far as it will go. Okay, if you need some help with this, ask your parents. Stretch it out as far as it will go, and then just take any object and drop it in in the blanket. That's how you represent it. Okay. If anybody wants to. But anyway, moving on. Now then, we can finally talk about the characteristics of a black hole. What is it? It contains something called a singularity at its center. I need everyone to look at the screen now. This is the most important point in the presentation, probably. Now, what is a singularity? It is a point that contains all the black hole's mass. And I repeat, point. I am not joking. It is just a point with no surface or volume, and it's just a point. If you were to draw, it's just a dot in space-time, to put it simply. But it has a lot of mass and infinite density. To put it simply, it has infinite mass and infinite density. So the gravitational well in space-time for a black hole is just a hole. There's no bottom. It literally has infinite gravity. I'm going to repeat this part again. A singularity is a point with no surface or volume, yet all the mass of the black hole, meaning that the gravitational well of a black hole has no bottom. It is infinitely powerful. It has infinite gravity, to put it simply. This means that a black hole's properties truly melts the mind. Go on.
So the strongest and biggest gravitational well is the gravitational well of a black hole.
Period. There is no way around it. A black hole's gravity is the single strongest in the universe, no matter what we're talking. Of course, the size of the black hole means that some black holes might have bigger wells, but they still have no bottom. That's the whole point. So, what is the event horizon? This is something we have to know. Simple way to put it, it's an imaginary circle inside the black hole. Anything that goes beyond this circle into the black hole, we don't know what happens. It's unknown to us. Why? When black holes are born, they have an escape velocity of 3 million meters per second. So because they gain mass from there, because they grow from there, the escape velocity only increases above 3 million meters per second. Now, does anyone know what the simple way of putting 3 million meters per second? Why is that number important? Does anyone know?
Sorry,
Sorry,
what?
I didn't understand your question.
So why is the number 3 million meters per second important?
Because it's the escape of velocity of the black hole.
It's not just that. There's a very specific reason. Do you know what that is?
Like they turn forming big, like rotating around something like that.
Because
3 million meters per second is the speed of light. Yes, when black holes are born, their escape velocity is 3 million meters per second, or light speed. Because they only gain mass from there, the gravitational well gets stronger, and the escape velocity goes beyond the speed of light, which means that light itself, which is scientifically the fastest thing in the universe, cannot escape a black hole. The event horizon is...
So that's why it's called a black hole, because it's black.
Yes. We get all our information about black holes from light. Any event beyond the event horizon is unknown to us, which is why it's given that name. Light cannot escape the event horizon. The event horizon, you cannot see beyond the horizon, right? On Earth, you cannot see what's beyond the horizon. So any event beyond the horizon is unknown to us, which is why we call it that.
Okay.
But yes, light itself cannot escape a black hole. Once you get near the event horizon, you are dead. It's that simple. If you go beyond the event horizon, there is no way of returning, period. But why? Why can nothing go beyond light speed? No one will know. I don't think any of you will know this answer, so I'll give you the answer. E is equal to mc squared. Has anybody heard this equation before?
No.
I thought not.
By Albert Einstein.
Yes, good job, Kshitij. Yes, it's Einstein's famous equation. E is equal to mc squared. M stands for mass. C is the term we use for the speed of light. And E is equal to energy. Now, if you reorder this, I did the algebra, but long story short,
Can you repeat what stands for C?
Yes.
C is the speed of light. If you look at the presentation, it's there.
So
C,
E is energy, M is mass.
yeah.
And C is the speed of light.
Yeah. Now, mass and energy are variable, but to put it simply, this basically says that the closer you get to energy, the speed of light, the closer you get to the speed of light, you need exponentially more energy. Long story short, you need infinite energy to get to light speed, just to get to it, not even to break light speed. And because of the law of conservation of energy, which states that, well, energy cannot be created or destroyed, only transformed from form to form, you cannot have infinite energy because there is no place where you can draw infinite energy from. Therefore, you cannot go faster than light speed, period. So nothing can go beyond light speed. If you look at this graph down here, let's just imagine that this is energy, and that this is the energy here, and this is the percentage of the speed of light. So right, this is approaching 100%, and this is pretty slow by comparison, okay? So you need energy to keep, as you get closer and closer to the speed of light over here, you need more and more energy. You need to get to infinite, and this graph will only go up from here, basically, which means that you need infinite energy to get to the speed of light, which is, as I said, impossible. So, because of this, it is impossible to go beyond the speed of light. Just impossible. There's no way around it. You cannot get to the speed of light, and there is no way you can exceed the speed of light. Just period. There is no argument. Now then, I know everyone's wondering about this. What happens if you fell into a black hole?
You will die, obviously.
Yes, but
and we'll be like you feel like crunched or something.
actually
the gravity will crush us.
that's where everyone's wrong.
What?
That's where you're wrong, but I'll explain why. But first, let me tell you what happens from people who are looking at you falling into a black hole. God knows how they even A, see you, and B, why you're near a black hole in the first place. But what happens in the outside? You will appear to freeze in time, turn red, vanish, the end. That's what happens from the outside. Why? Now, this is another scientific property called a Doppler shift. Doppler shift basically states that so from a light source, if a light source moves closer to us, the light turns blue because its wavelength becomes smaller. Everyone knows that light is a wave, right?
Yeah.
It's also a particle, but for the purposes of this presentation, let's just take light as a wave, okay? Now, a wave has its own length, the length between two peaks or two troughs, if you guys know what that means. But basically, the wave has a certain length that's called the wavelength, okay? Now, what Doppler shift says is that based on the distance from a source of light to us as, Earth, the color of the light changes slightly based on how far away the object is and whether it's moving towards us or away from us. Okay, so if you're moving closer, the light becomes squished together, to put it simply, and it becomes blue shifted. It appears to turn blue. If it's moving away, it turns red shifting. And being inside a black hole is about as far as is possible. Not humanly possible, as is possible, just period. So the light is infinitely redshifted. So everything you're wearing seems to turn red and then vanish once the light can't escape the black hole's gravity. What happens to you? Well, this is where it gets confusing. If you are looking, theories say that you see time fast forward and the entirety of the universe, as in just everything that has and ever will happen in the universe. You literally see into the future. That's the simple way to put it. I could tell everyone's confused. Does anybody want
Actually, I'm not confused. Like, if you're looking, like your eyes are open, you can see what happens in the future of the universe.
Yes, until you die. But what happens while you die? this part might cause some loss, but I want everyone to try and be serious here. How it kills you. First way, you die quick. Because the singularity is so small, the gravitational forces on your feet are much stronger than your head. Yes, I'm not joking about this. Everything I'm saying here is scientifically real. But yeah, to put it simply,
Wait, the gravitational force in your feet is stronger than on your head.
because see, look, let me put it this way. See, look, the distance from Earth's core to your feet is not much different from Earth's core to your head, right? Given how Earth is pretty big in comparison, right?
Yeah.
Now then, whereas in a singularity, it's just a point, which means that distances of a few centimeters will seem like millions upon millions of kilometers. Okay. So the gravitational forces on your feet are much stronger because it's closer to the singularity than your head. Okay. So what this means is that if you were to fall on feet first, you are pulled apart atom by atom as each one is pulled into the black hole. This is scientifically called spaghettification. I wish I was joking, but I'm not. This is the scientific term. Spaghettification is the first potential method of being killed by a black hole. The second method, you die very quickly. Pretty quickly after you have entered the event horizon, you are burnt to death because there's a firewall. That's the second theory. But basically, you're dead if you fall into a black hole. But you need to remember this spaghettification stuff and burning by firewall. Anybody want me to repeat anything from this slide?
Is it firewall? Okay, firewall. Okay.
Just think literally, not if anyone's parents are into like computers and stuff, don't think that. I mean literally a wall made of fire. That's what they mean. So yeah,
It's actually a wall made out of fire, or not?
basically, just that's the simple way to think of it. A literal wall of fire. But yes. Anything else anyone needs me to repeat?
I didn't understand what is that spaghettification.
Hang on, let me just go back to the slide. So, what spaghettification is that because, see, look, the singularity is so small compared to you that the distance between your feet and your head is massive compared to the singularity, okay? So if you were to fall in feet first, the gravitational forces on your feet are stronger than those on your head because it's closer to the singularity. So the forces are so strong that your feet are pulled apart atom by atom. You're pulled apart atom by atom as each part of you is torn into the black hole. That process is called spaghettification because your body is literally being stretched, just like spaghetti.
I have like one more doubt. It's from the first slide you said, like the first slide.
Go on.
Like, what is the thing? Like the first wave, like not the wave to two neutron stars binding. The other way about 20 solar masses, blah blah blah. I didn't
A
understand
star of
that.
more than 20 solar masses, if it collapses, it forms a black hole. If you remember when I talked about high mass stars, I talked about how they collapse and form a supernova. Yeah, if a star more than 20 times the mass of the sun collapses, that forms a black hole.
Okay, thank you.
But yes, now the next stuff. Black holes can die. More specifically, they evaporate. How? This is very confusing and this delves into quantum physics. I've tried to simplify this for you, but feel free to stop me at any point. This is still very confusing. The process is called Hawking radiation, named after the late great scientist Stephen Hawking. Now then, in order to understand Hawking radiation, we need to understand empty space because it's not very empty. So here's what happens. In empty space, it's full of pairs of virtual particles I mean virtual particles that come into existence and then annihilate each other almost immediately. Okay, so if you want me to repeat that, pairs of virtual particles, aka particles that aren't real, they come into existence, destroy each other almost immediately. That's what empty space is. But when this happens on the event horizons, one of the particles is pulled into the black hole, whereas the other one escapes because the black hole isn't strong enough. This is quantum physics, so don't ask me how that's possible. I'm still trying to learn this myself. So one of the particles goes into the black hole and the other one escapes despite the black hole trying to pull it in. The particle that escapes the black hole becomes a real particle. Okay, but because the black hole failed to pull that particle in, it lost a little energy. Now, this thing happens millions of times a second, so despite it losing a very minute amount of energy, this slowly begins to add up. Anybody want me to repeat anything? Is there anything anyone wants me to repeat?
No.
Great, because what this means is that the black hole becomes smaller. Now, as it gets smaller, it also begins to heat up. So, at about the size of an asteroid, a black hole is radiating energy at about room temperature. It's about 20 or so degrees Celsius. Once it gets to the size of a mountain, it's radiating at the temperature of a sun, which is about 6,000 degrees Celsius. Yeah, it's a big jump. So yeah, and just before it evaporates away, it radiates the energy of a billion nuclear warheads or a supernova. So when a black hole dies, it basically goes supernova, to put it simply, without anything actually exploding in the common sense. Just the energy of a supernova is released. That's all you need to know.
Okay.
I didn't understand what you just said.
Do you want me to repeat the entire slide?
Now,
Somebody said that they were confused.
like I just didn't understand like one small part in the slide.
Which part?
It just like when it goes to a supernova, like doesn't a supernova explode? So like how can, if this turns into a supernova, how can it explode? How can not
It
explode?
doesn't turn into a supernova. What happens is just before a black hole dies, the energy it releases is the same as a supernova.
Okay.
So it doesn't go supernova, but just before it dies, the amount of energy it releases is comparable to supernova.
Okay. Thanks.
So we're gonna have a quiz now, but before I even give you any questions, anybody want me to repeat anything I said before this? Just anything. No? Okay, so I want everyone to post their answers in a private chat if possible. Look. Okay, so in 3, 2, 1. What are the 2 ways a black hole can be formed? I want your answer in a private chat.
Can you explain what you mean? You mean collapsing or form?
I just said formed. I mentioned 2 methods in which a black hole is created. What are those 2 methods? You need both answers to give me for me to give you the point. supernova, to put it simply. Basically, when a star with more than 20 solar masses collapses, or when two neutron stars collide. And also, I haven't really been too worried about this, but in terms of spelling, comments will be reserved after class.
Sorry, I didn't hear you.
Nothing. Question 2. What is the space-time continuum? Is a four-dimensional mathematical model of the universe. Question 3. What's Go ahead. What's the fourth dimension of reality? Question 4. How do you visualize gravity? Well, in space-time. What is a singularity? Private chat answer, and if any part of it is wrong, you get no marks. Just a point with no surface or volume, but all of the mass of the black hole. What you've done is you've more or less described a black hole as a singularity.
Okay.
If you, this is going to be uploaded on YouTube, so you can go see what you've done wrong. Okay. But anyway, what is the escape velocity of the black hole the moment it's born? Why can we not exceed light speed? You don't need to explain the full equation and mathematics behind it. I just need a simple reason. MC squared. You need infinite energy to reach, let alone exceed light speed, making it impossible. The end. Question 8. Why is it that you appear to turn red when falling into a black hole? It's C. The wavelength is elongated as it tries to escape the black hole. It's red shifted. Remember, the light itself won't be red. All that will happen is that it's elongated. It will turn red. Well, what is the scientific name for the? Yeah, it's spaghettification. It's as ridiculous as it sounds, but physics. What is the second potential method of death by black hole? You are burnt alive by a fireball. That's correct. What you're trying to Nishka, what you're trying to explain there is, well, spaghettification, to put it simply. So yeah, sorry, but you're not correct. What is the name of the process that evaporates a black hole? Yeah, it's Hawking radiation, named after the late great Stephen Hawking. Yeah, I'm sure all of you have heard of him. What is it? You guys got your questions. Go ahead. Yes, the answer is B. Pairs of virtual particles use their existence to annihilate a black hole. If you want more in-depth, please, you can just look at the YouTube video later, or if you're watching this on YouTube, you can just rewind. But, so, that is the quiz. Now then, let me announce the scores. So, there is a tie, but not for first place. Arnika, you won full marks, 12 out of 12. Good job. Nishka and Ditya, you are both tied at 10 out of 12. But I'm not going to have a secondary quiz just because, well, it's second and third place. You guys can, either way, I don't feel like giving one either. It's too complex, this subject. But anyway, well done, all of you. I'm honestly impressed you guys got this much. I'm not going to lie. This was very well done. Now then, does anybody have any questions for me before we end?
No.
No?
No.
Okay, great. So that is it. If you guys have any artwork or something you want to send us, please.
Actually, I have one last question.
Okay.
You said about that spelling, blah, blah, blah. What about that?
Yeah. About the spelling. From next class onwards, if you don't spell anything correctly, you're not gonna get the mark.
It's not fair.
You spelled collapses wrong. There's no other way around it. That's not even a complex word. So,
Fair. Not fair. Not fair.
I mean, I put up with it for long enough. It's been 4 weeks. And anyway, next week, we're still going to be going over black holes.
Okay.
Okay, just to make this a little fairer for you, Nishka, here's what I'll do. If the spelling for anything major, like any important point, is wrong, then you don't get the mark. But if it's just a random word, then that's okay.
Okay.
Like is or are, something like that.
Basically like that. But if it's something important, then, well, you know,
Like spaghettification or something.
you spell that wrong, no marks for you. But yeah, so I think that is everything. So if you guys have any artwork or anything you want to post to us, remember to email it to classesforkids123@gmail.com. If you want to, or please remember to subscribe to the YouTube channel just so you can be caught up on everything. And if you're missing anything, then please look over. Just like go over and look over the previous classes. Okay. As far as I can tell, that is everything, I believe. So I'm going to